I am Chiara Marsigli from the German Weather Service. I would like to talk about some potential benefits we see in the digital twin for the user in the short-term forecast. The German Weather Service, we are not part of the DestinE project for the weather part, but we are in the German Weather Service in a trilateral cooperation with Italy and Switzerland. We are involved in a project which is GLORI, which is about a global to regional digital twin based on the ICON model. So that's why we are here to talk about digital twin and to also try to exploit the synergies between this project and DestinE. So we are talking about weather. So this digital twin is meant for weather, for the impacts of related to the weather for the short term. So typical scale of the weather forecast. And it's based on the ICON model, as I said, both global, where we want to go for the storm resolving scale, to the regional scale, down to the 500 meter, where we focus in the first phase of the project to two regional domains, which is the Alpine domain and the peninsular Italian domain. And this is to build a prototype where we can exploit this idea and this facility of the digital twin. So as I said, the idea is to have a twin which is configurable and on demand, and we focus on the model which is ICON, operational also in the services. The partner of this project are German, Italian, and Swiss institutions. You can see in the slide to the left the partnership of the project. And we aim at having a digital twin for these components running in a distributed way, so using the HPC facilities in the different centers, which are sort of illustrated in the right panel. I will go more in a couple of details about this, and this is supported also by a bilateral cooperation program between Italy and Germany. So what is more the core of the digital twin, and what are the applications and how the user can benefit from this short-term digital twin application in general, because in general we cover the aspects of the weather forecast. So there is, of course, a development phase which is supporting the capability of the digital twin, which goes to a series of needed scientific and technical improvements and adaptations, which I will go a bit through next. And then we have the core of the digital twin, where we focus on really having the system running, and the application part. In this first phase, our applications, they are targeted to energy and health parts, and also to the catchment level, where, of course, the hydrology becomes very important. Two layers supporting all this effort are the ensemble forecasting layer, where we can have an uncertainty estimation associated to the forecast given by the digital twin, which is, of course, also a support for the user to know the level of uncertainty associated to these scenarios. And the HPC accelerator will permit to the twin to run in the time which is required to obtain a timely response. We seek for synergies with destination Earth, and this could also be done at the level of the data lake. So what are the main aspects we think are relevant in the digital twin approach for the weather, and how we want to include, and what can be relevant for the user? Of course, one thing which could be very beneficial is to exploit the high resolution observations available for the atmosphere, and how to include them in the model in the best way, so we can benefit from the ensemble data assimilation algorithm, which permit to really include high resolution data going from the radar data 3D to new sensor and technologies which are maybe detailed for the boundary layer, or even the new technology like cameras or drones. And in this case, it can be assured the ingestion of moisture-related quantities, which are really relevant for the impacts, and with a very frequent uptake. And about the importance of frequent uptake, I would like to show in this slide. This is based on something existing at DWD. There is an experimental system, which is a rapid update cycle system, and where we refresh continuously the analysis to which the model start and have hourly runs. And in the left panel, you can see the value, the score of these hourly runs. And every line is a run started in subsequent hours. And the best forecast is the lower level of the curve. So you see that the score of the short-term forecast degrades very fast in the first hours. And that's why it's very important to have a frequent uptake to be able to fulfill the user need, and they can always benefit from the fresher forecast. Components which have relevance for the usage of the twin are, for example, those related to the land atmosphere feedback, where a better description of the hydrological cycle may have an impact, because if the parameterization of the surface and subsurface flow, they permit to have a better description of the processes impacting the hydrological cycle. And about this, there is a connection, the DWD level, and a collaboration in a co-design project between the German Weather Service and the flood forecasting centers, regional in Germany, to design together how to best exploit and how to best use the high resolution forecast, and in the perspective also the digital twin tool for the hydrological application. Very important for the flood prediction are the scale, the short term, and also the high resolution, which is provided by the digital twin approach for the weather. Because you can see in this plot, we have an example of a tool which can help the flood prediction. This in the graph you see precipitation amount. This black line, which is horizontal in the plot, represent the precipitation recorded in a station, in a ground station, during the flood events occurring in central Italy, in central Germany, sorry, in Central Europe in 2021. And you see how the different forecasts that they try to address this forecast, to forecast this level of precipitation, and from the global to the European model, only to the regional model and the high resolution, is possible to really capture the signal of this intense precipitation, which is very relevant for the applications and for the institutions related. Also about land atmosphere feedback, a very important part in the description of the surface energy and water balance, and the inclusion of the urban parameterization of the urban component, which is very much present in our domains, and they have are relevant for the short term. So, for example, the estimation of the urban island effect. And for this, there is also a component which will be part of the twin, which is related to the urban modeling. And in this figure here, you can see to the left how the city of Rome is represented, where you are now. Okay, you're a bit to the south east. And instead, in the right hand panel, you can see how the inclusion of the urban effect impact the temperature in the night due to the effect of the urban. And this is an effect which, of course, can be used in many applications. And this also is a perspective also in terms of urban flood with another kind of parameterization. Finally, another impact which we would like to consider in the twin, which we are considering in the twin, and which I think is important, is the part related to the aerosol modeling. So thanks to a coupling with the aerosol and reactive trace gases model, there is the possibility to have a real forecast of some aerosol components like the mineral dust, which are relevant for the energy production, or the pollen, which are very relevant for the earth. So in a framework of usage of the twin, these are also components which can be beneficial. And with this, I thank you for attention.